question of whether grounding both the mast and coax cable of an antenna system is redundant is a valid one, rooted in the historical evolution of antenna and cable television systems. In the early days of television broadcasting, antennas were typically installed on rooftops or towers. These antennas were connected to the television receiver using twin lead wire. Twin lead wire, unlike coaxial cable, lacks an electrical shield. This absence of a shield made it unsuitable for grounding in the same way that coaxial cable could be grounded. Consequently, the National Electrical Code, or NEC, mandated grounding the antenna mast. This requirement served as a protective measure against electrical hazards stemming from lightning strikes or accidental contact with fallen power lines. The grounding of the mast provided a direct path to earth for any stray electrical currents, safeguarding the television equipment and the building's occupants. As cable television, or CATV, systems began to emerge, the distribution of signals relied on overhead coaxial cables. These cables were often routed in proximity to power lines, thereby elevating the risk of electrical surges being induced into the cable system. To mitigate these risks and protect subscribers from potential electrical hazards, the NEC introduced the requirement to ground the CATV coax cable at the subscriber's residence. This grounding provided a safety mechanism against voltage surges and ensured that any stray currents would be safely directed to ground. Today, modern antenna and satellite dish installations predominantly utilize coaxial cabling. Given this widespread adoption of coax, the question of whether grounding both the mast and the coax cable constitutes a redundant safety measure naturally arises. The NEC, however, continues to require both grounding measures for several reasons. Firstly, antenna mast grounding provides a low resistance path to ground. This low resistance path is critical for dissipating the energy from lightning strikes and power surges effectively. Secondly, grounding the mast protects against electrostatic discharge, or ESD, build-up in the antenna and the mast structure itself. Electrostatic discharge can damage sensitive electronic components in the antenna or connected equipment. Regarding coax cable grounding, firstly, it shields the cable from electromagnetic interference, or EMI, and radio frequency interference, or RFI. This shielding ensures signal integrity and prevents unwanted interference from affecting the quality of the received signal. Secondly, the coax cable grounding serves as a ground path for any surge currents that may be induced on the cable. This helps to protect connected equipment from damage due to electrical surges. The NEC is not a static document. It undergoes regular revisions and updates to reflect technological advancements and incorporate best practices in electrical safety. It is conceivable that future revisions of the NEC might consider eliminating or modifying the requirement for grounding antenna masts in situations where coaxial cabling is employed. However, any such change would necessitate a comprehensive evaluation of several key factors. One factor is the potential for electrical hazards arising from lightning strikes or accidental contact with power lines. Another factor is the effectiveness of grounding the coax cable as a substitute for grounding the mast in providing adequate protection against these hazards. A third factor is the compatibility of various antenna and cable designs with grounding requirements. Different antenna designs and cable types may have varying grounding needs and characteristics. In conclusion, the grounding requirements for antennas and CATV systems were initially established to address distinct hazards associated with separate systems. Over time, these requirements have evolved to provide a degree of redundant protection for modern coaxial-based systems. The question of whether the continued requirement for grounding both the mast and coax cable remains necessary is an ongoing evaluation, particularly in light of advancements in technology and evolving understanding of electrical safety. Future revisions of the NEC may well address this issue and potentially lead to the elimination of redundancy where it is deemed safe and appropriate. In the interim, it is crucial to adhere to the current NEC requirements for proper grounding to ensure the continued safety and integrity of antenna and CATV systems. The NEC serves as a comprehensive guide to safe electrical practices, and compliance with its provisions is essential for protecting individuals and property from electrical hazards. Let's consider how the NEC addresses grounding and bonding. specifically focusing on Articles 810.15 and 820.100. These sections are critical for understanding the requirements for antenna systems and cable systems, respectively. Article 810.15, which pertains to amateur radio and receiving antennas, details the grounding requirements for the mast and support structure, as well as the lead and conductors. The primary goal is to protect against lightning strikes and other electrical hazards. Here are the key points. Firstly, the grounding conductor must be copper, aluminum, copper-clad steel, bronze, or other corrosion-resistant material. Secondly, the grounding conductor must be securely fastened to the mast or support structure. Thirdly, the grounding conductor should be as short as practicable and run in a straight line to the grounding electrode. Fourthly, the grounding electrode must be one of the following: a grounding rod or pipe, the building's metallic water pipe system, the building's metallic frame, or another approved grounding electrode. Fifthly, the size of the grounding conductor must be in accordance with NEC Table 810.16. This table specifies the minimum size of the grounding conductor based on the size of the antenna lead and conductor. Sixthly, a lightning arrestor should be installed in the antenna lead and conductor as close as practicable to the point where the conductor enters the building. This arrestor helps to protect the receiver from voltage surges caused by lightning. Article 820.100 addresses the grounding and bonding requirements for coaxial cable systems. This section is designed to protect against electrical hazards associated with cable television, satellite dishes, and other similar systems. Here are the key points. Firstly, the outer conductive shield of the coaxial cable must be grounded as close as practicable to the point of entry into the building. Secondly, the grounding conductor must be copper, aluminum, copper-clad steel, or other corrosion-resistant material. Thirdly, the grounding conductor must be securely fastened to the coaxial cable shield. Fourthly, the grounding conductor should be as short as practicable and run in a straight line to the grounding electrode. Fifthly, the grounding electrode must be one of the following: a grounding rod or pipe, the building's metallic water pipe system, the building's metallic frame, or another approved grounding electrode. Sixthly, the size of the grounding conductor must be in accordance with NEC Table 820.100. This table specifies the minimum size of the grounding conductor based on the size of the coaxial cable. Seventhly, a bonding connection must be made between the coaxial cable shield and the building's grounding system. This bonding connection helps to equalize the potential between the cable system and the building's electrical system, reducing the risk of electrical shock. The NEC provides specific tables to determine the appropriate grounding conductor size. For antenna systems, Table 810.16 dictates the minimum size based on the size of the antenna lead and conductor. For example, if the lead and conductor is 10 American wire gauge copper, the grounding conductor must be at least 10 American wire gauge copper or 8 American wire gauge aluminum. For coaxial cable systems, Table 820.100 specifies the minimum size based on the size of the coaxial cable. For instance, if the coaxial cable has an outer diameter of 0.375 inches, the grounding conductor must be at least 14 American wire gauge copper or 12 American wire gauge aluminum. Understanding the rationale behind grounding requirements is crucial for ensuring safety and compliance. Grounding provides a low impedance path for fault currents, protecting equipment and personnel from electrical shock and damage. Proper grounding also helps to minimize electrical noise and interference, improving signal quality. Bonding, which involves connecting different metallic parts of a system together, helps to equalize the electrical potential between them. This reduces the risk of electrical shock and prevents the buildup of static electricity. Regarding the potential redundancy of grounding both the mast and the coax cable, it is important to recognize that each grounding method serves a distinct purpose. Grounding the mast primarily protects against lightning strikes and other high-voltage surges, while grounding the coax cable primarily protects against electrical noise and interference. In some cases, both grounding methods may be necessary to provide adequate protection. The NEC recognizes that there are situations where grounding requirements may be redundant or unnecessary. For example, If an antenna is located in an area with low lightning activity, it may not be necessary to ground the mast. Similarly, if a coaxial cable is shielded from electrical noise and interference, it may not be necessary to ground the cable. However, it is important to consult with a qualified electrical inspector to determine whether grounding requirements can be safely waived. The NEC is a complex and ever-evolving document. It is important to stay up to date on the latest changes and interpretations to ensure compliance. Electrical inspectors and other qualified professionals can provide guidance on specific grounding requirements and help to ensure that electrical systems are installed and maintained safely. To further clarify the specific code requirements related to antenna and CATV grounding, let's delve into additional details from the NEC and related best practices. Firstly, NEC Article 810 covers radio and television equipment, including antennas. Specifically, NEC 810.15 addresses grounding, requiring that antenna masts and metal structures be grounded. The grounding conductor should be at least 10 American wire gauge copper or 8 American wire gauge aluminum. The grounding electrode must be as close as practicable to the antenna location. Secondly, NEC Article 820 pertains to community antenna television or CATV and radio distribution systems. NEC 820.100 outlines the grounding and bonding requirements for CATV systems. The coaxial cable shield must be grounded at the point where the cable enters the building. The grounding conductor should be at least 14 American wire gauge copper or 12 American wire gauge aluminum. A bonding connection must be made between the coaxial cable shield and the building's grounding system. Thirdly, NEC 250.50 provides general requirements for grounding electrodes. This section specifies the types of electrodes that can be used for grounding, including metal underground water pipes, metal frames of buildings, and ground rings. The grounding electrode must be sized in accordance with NEC Table 250.66. Fourthly, NEC 250.52 lists types of grounding electrodes that are not permitted. This section prohibits the use of certain types of electrodes, such as gas piping systems and aluminum electrodes. Fifthly, NEC 250.92 addresses bonding of metal enclosures. This section requires that metal enclosures containing electrical equipment be bonded together to create a low-impedance ground path. Bonding helps to prevent electrical shock hazards and reduce electrical noise. In addition to the NEC requirements, there are several best practices that should be followed when grounding antenna and CATV systems. 1. Use corrosion-resistant connectors and hardware. Grounding connections should be made with connectors and hardware that are resistant to corrosion. This will help to ensure a reliable grounding connection over time. 2. Protect grounding conductors from physical damage. Grounding conductors should be protected from physical damage by routing them through conduit or other protective measures. 3. Inspect grounding connections regularly. Grounding connections should be inspected regularly to ensure that they are tight and free from corrosion. 4. Use a ground tester to verify grounding effectiveness. A ground tester can be used to measure the resistance of the grounding system. The resistance should be low, typically less than 25 ohms. 5. Consult with a qualified electrician. If you are unsure about any aspect of grounding antenna or CATV systems, consult with a qualified electrician. An electrician can help you to ensure that your grounding system is safe and compliant with the NEC. It is important to note that the NEC is a minimum standard. In some cases, it may be necessary to exceed the NEC requirements to provide adequate grounding. For example, if you live in an area with frequent lightning storms, you may want to install a more robust grounding system. Ultimately, the goal of grounding antenna and CATV systems is to protect people and property from electrical hazards. By following the NEC requirements and best practices, you can help to ensure that your grounding system is safe and effective. The history of grounding requirements reveals a progressive adaptation to evolving technologies and an increasing awareness of electrical safety. Early electrical systems often lacked comprehensive grounding, leading to significant risks of electrical shock and fire. As electricity became more prevalent, the need for standardized grounding practices became evident. The NEC, first published in 1897, has played a central role in establishing and refining these standards. In the early days of radio and television, antennas were often simple wire structures, and grounding practices were not well defined. As antenna technology advanced, the NEC began to incorporate specific requirements for grounding antenna masts and lead-in conductors. These requirements were primarily focused on protecting against lightning strikes and other high-voltage surges. The advent of CATV systems introduced new challenges for grounding. Coaxial cables, while providing better signal quality, also presented a potential pathway for electrical hazards. The NEC responded by adding requirements for grounding the coaxial cable shield at the point of entry into the building. Over time, the NEC has continued to evolve, incorporating new technologies and addressing emerging safety concerns. For example, the rise of satellite dishes led to additional requirements for grounding satellite dish masts and associated equipment. The NEC also addresses the use of surge protective devices, or SPDs, which can help to protect against voltage surges caused by lightning or other electrical events. SPD should be installed in accordance with NEC Article 285. The question of whether grounding requirements can be relaxed in certain situations is a complex one. The NEC generally errs on the side of caution, requiring grounding in most cases to ensure a high level of safety. However, there may be situations where grounding is not strictly necessary. For example, if an antenna is located indoors and is not exposed to lightning or other electrical hazards, it may not be necessary to ground the mast. Similarly, if a coaxial cable is shielded from electrical noise and interference, it may not be necessary to ground the cable. However, it is important to consult with a qualified electrical inspector to determine whether grounding requirements can be safely waived. The inspector will consider the specific circumstances of the installation and the potential risks involved. In addition to the NEC, other organizations, such as the Institute of Electrical and Electronics Engineers, or IEE, also provide guidance on grounding and bonding. The IEE Standard 142, also known as the Green Book, is a comprehensive guide to grounding and bonding of electrical systems. This standard provides detailed information on grounding principles, grounding electrodes, and bonding techniques. Staying informed about the latest developments in grounding technology and practices is essential for ensuring the safety and reliability of electrical systems. This includes attending industry conferences, reading technical publications, and participating in continuing education courses. By staying up to date, electrical professionals can provide their customers with the best possible service and help to prevent electrical accidents. The NEC is updated every 3 years, so it is important to have access to the latest version. The NEC can be purchased from the National Fire Protection Association, or NFPA, or accessed online through various subscription services. Understanding the NEC is crucial for anyone involved in the design, installation, or maintenance of electrical systems. It is a complex document, but it is essential for ensuring the safety and reliability of electrical installations. Grounding and bonding are fundamental aspects of electrical safety. By following the NEC requirements and best practices, you can help to protect people and property from electrical hazards.